For this section, we're given a description of shapes, and part of our job is to be able to place this shape in a coordinate plane. Now, I'm going to try and do this in the most convenient way possible, so let's read the instructions and see how we can put it in the coordinate plane in an easy way. The first one is a right triangle with leg lengths of 7 and 9 units. And when we're done with that, we're going to find the length of the hypotenuse. Okay, it's a right triangle. I need a 90-degree angle, and if I use horizontal and vertical lines, that will give me nice 90-degree angles. So these legs of 7 and 9, I'm going to place horizontally and vertically, and that will be the easiest way in the coordinate plane. So let's take a look right here. We've got a leg length of 7, so I'll go 1, 2, 3, 4, 5, 6, 7. And a leg length of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And the hypotenuse just connects those ends. So we now have our right triangle. There's our right angle. Easy to draw. This is 7 units. This is 9 units. And we're now ready to set this up for finding the length of that. We're going to use the Pythagorean theorem because this is a right triangle. So let's go back here. We've got 7 squared plus 9 squared, and that will equal c squared, or the length of our hypotenuse. 7 squared is 49 plus 81, and that equals c squared. 49 plus 81 gives us 130. And we need to eliminate this square, so we're going to do that by taking the square root of both sides. Now, the square root of 130 is not a nice number, so we've got two options. Option number one, if we want the exact solution, we leave it as the square root of 130. If we want a decimal approximation, we're going to plug that into the calculator, so we get the square root of 130, and that equals approximately 11.4 units. So pay attention. If it wants exact numbers, leave it this way, square root of 130 units. If it wants rounded, do it that way, and keep the appropriate number of decimal places. All right, let's take a look at our second one. We are now tasked with drawing an isosceles triangle with a base length of 60 units and a height of 50 units. I want to draw a picture of this on here because this one's a little tougher to put on the coordinate plane. So we have an isosceles triangle. That means that these two sides are going to be congruent to each other, and the base length right here will be 60. So we want this picture to be translated over there. We know the height, which is this, dropped straight down, is 50. And that height is going to be perpendicular to here. So the most convenient way to draw this is going to be to have this as a horizontal line and this as a vertical line, and that would set up my isosceles triangle nicely in the coordinate plane. There's one more thing that we need to recognize on this. If we drop this straight down, it's going to cut this line in half right there. So I'm going to end up having 30 units over here and 30 units over there, and that'll make it a little bit nicer. Now over here, I'm going to go by units of 10. So our 60 units will go from 0 to 6 here. There's 60 units. And remember, we had 30 units on one side, 30 units on the other. So right here on that 30 is our height, which is 50 units. So I'm going to go up to 5, and then we've got to connect these two. And here are the legs for that. These are congruent to each other. Our last task is to find the length of one of these legs. And this diagram has created two right triangles. So I'm going to use this right triangle right here to figure out the length of that leg. This is 50 units, and this is 30 units right there because we cut that 60 in half. So let's go ahead and draw that triangle now on the board, and we will use our Pythagorean theorem again because we're working with a right triangle. So here's our right triangle. We've got 50 units there, 30 units there, and we're looking for the length of that leg. Set this up. We've got 50 squared plus 30 squared equals c squared. 50 squared is 2,500. 30 squared is 900. And 2,500 plus 900 is 3,400. So we've got 3,400 equals c squared. We need to eliminate the square again, so we'll take the square root, take the square root of that. So the square root of 3,400 is, again, not a nice number. We approximate that with 58.3 units. Or if it asks for the exact value, we're going to leave it as the square root of 3,400 units. And we have figured out the length of the leg. Going back to our diagram, if we needed to figure out the length of the other leg, we've already done that because this is an isosceles triangle. So we figured out the length of that one. This one would be exactly the same. So we have no further work to do and we know all the dimensions. Thank you.